Now we discuss some important numericals which is related to the mirrors formula and magnification. What is the mirrors formula? 1 by f is equal to 1 by v plus 1 by u. This is the mirrors formula or mirrors equation. Magnification formula, height of the image to the height of the object, or it is a ratio of image distance to the object distance. So based on these two formulas, we are going to solve the numericals. See, this is a problem which we have in the textbook page number 14. This is an example problem. Okay, an object is 4 centimeter in size, placed at 25 centimeters in front of a concave mirror of focal length 15 centimeters. So first we have to draw the ray diagram. This is a concave mirror. Okay, pole, focus, center of the curvature. The distance between pole and focus is called focal length. Okay, so what is the focal length is given? Focal length is 15 centimeters given. So very important, first you have to find what is given. Focal length is given, that is 15 centimeters. So up to here 15 centimeters, then up to center of the curvature will be 30, because already we discussed this relation. This is focal length, this is radius of the curvature, r is equal to 2f, f is equal to r by 2. Now, object is placed at 25 centimeters. This is object distance u. Where it is placed? At 25 centimeters. Up to f 15 centimeters, up to c 30 centimeters, then 25 should lie between 15 and 30, right? That means object is placed between focus and center of the curvature. Okay, what is the height of this object? Height of this object is 4 centimeters. Okay, object is placed at 25 centimeters. This gives you object distance 25 centimeters. Okay, height of the object HO is equal to 4 centimeters. This value is 4 centimeters, height of the object. Now what we have to calculate? We have to calculate the image distance, where the screen should be placed to get the clear, sharp image, in the sense clear image. So the distance between that mirror and the screen is called image distance. Okay, now we have to find image distance v as well as size of the image, that means height of the image. So these both should be calculated. Okay, first we are going to write the nature of the image, because already almost a diagram finished. When object is placed between f and c, we know that image forms beyond c. This is image. So what is the nature of the image? Inverted, real, okay, magnified or enlarged. Why it is called inverted image? Because image is formed downward the principal axis. Why it is called real image? This image formed due to the converging of reflected light rays. Enlarged image. Size of the image is greater than size of the object. That is why it is enlarged. So nature finished. Now we have to calculate the image distance first. V should be calculated. How do you find V? F we have, U we have to find the V. Okay, so which formula we have to use? This formula. 1 by f is equal to 1 by v plus 1 by u. This formula should be used. But before using the formula, we have to apply the sign convention. It is very, very important. Applying sign convention. This is concave mirror. The focal length of the concave mirror is negative, because this is incident ray direction. The ray from the object coming to hit the mirror this direction. This is incident ray direction. Now we are measuring focal length. The distance between pole and focus is called focal length. We are moving opposite to the incident ray. Then sign to be taken negative. Object distance, the distance between pole and object, we are moving P to the O, our direction is opposite to the incident ray, then sign to be taken negative. Object is placed upward principal axis, that is why sign to be taken positive. Okay, for unknown quantities we don't take the sign convention, later automatically they will come. To find the V, height of the 1 by F is equal to 1 by V plus 1 by U. This is the formula we have. So F value we have, U value we have, V value we have to find. So I will write the formula as 1 by V is equal to this plus 1 by U, if transposed to the RHS to LHS, becomes minus 1 by U. So 1 by F there itself, and this become 1 by F minus 1 by U. Okay, if you substitute the values, 1 by V is equal to 1 by F value how much here, minus 15, minus U value how much here, minus 25. Okay, next 1 by F is equal to 1 by minus 15 minus into minus plus 1 by 25. Next 1 by F is equal to LCM of 15 and 25. What is the LCM of 15 and 25? 5 table. 5 3s, 5 5s. These are the prime numbers. 5 3s are 15, 15 5s are 75. So 75 is the LCM. 1 into 1 is the numerator, 1 into what is the denominator in the first fraction? 15. What is the LCM? 75. In 15 table, when do we get 75? 15 5s. So minus into plus, minus. Plus 1 into this numerator, 1 into denominator 25, LCM 25. In 25, 3 times we get 75. 25 into 3, 75. 1 by F is equal to 1 into minus 5 plus 3 by 75. Minus 5 plus 3 minus 2. 1 by F is equal to minus 2 by 75. If you do the cross multiplication, okay, F is equal to minus 75 by 2. F is equal to minus 37.5. ఓకే, అలవాట్లో పొరపాటు 1 by F మనం రెగ్యులర్ రాస్తాం కదా, ఇక్కడ వచ్చింది అన్నమాట. దిస్ ఈజ్ 1 by V. ఓకే, 1 by V, రైట్? సో V is equal to how much? V is equal to minus 37.5. Okay, so we got V value, and finally we have to find the height of the image. To find the height of the image, this formula we have to use. Height of the image by height of the object is equal to minus V by U. Height of the image should be found. Height of the object already given 4 centimeters. U value already given minus 25. V value just now we got. Okay, then 3 values are there. This value can be found by using cross multiplication process. Height of the object is equal to how much? And height of the object 4 centimeters is equal to minus is in this formula. V value already negative, so already here minus is there. This minus is in the formula. We have to take this V value including with the negative side. So minus of minus 37.5 by U value minus 25. This minus get cancelled. Then this 4 is which is in the left hand side, dividing the HI, height of the image. If you transpose to RHS, multiplies this number. So height of the image is equal to minus 37.5 into 4 by 25. Okay, so if you do the simplification of this one with 5 table, if you go with the 5 table, 37.5 into 4 by 25. 5 5s, 5 7s and 5 5s, 7.5. Again 5 1s, 5 5s, 1.5. So 1.5 into 4, 6. So we are getting 6 centimeters, but plus by minus 6 centimeters. Why minus 6? Because image is formed below the principal axis, that is why negative. And also we have discussed in the previous magnification values, this image is real image. This image is real image. So sign to be taken negative. Okay, so in this way we have to solve the problems, and we have to find the nature of the image, height of the object, height of the image distance, object distance, anything is given. Using these two formulas, using the proper sign convention, we can solve it. Very, very important, sign convention. If you don't apply the sign convention, you will get the wrong answer. Please apply the sign convention before substitute the values in the formula. Before substitute values in the formula, apply the sign convention. Please note down this problem. This is a problem which we have second bit, applications of concepts, first problem. Okay, first we are solving the textbook numericals, then I will give you some extra numericals in the next part. Okay, so find the distance of image distance should be calculated. So V is equal to question mark. When an object is placed on the principal axis at a distance of 10 centimeters, so U is given 10 centimeters in front of a concave mirror whose radius of the curvature is 8 centimeters. When radius of the curvature is given, we have to find the focal length. Focal length is equal to half of the radius of the curvature. So that is equal to 4 centimeters. 8 by 2, 4 centimeters. Okay. So U value we have, R value we have, V value we have to calculate. Okay. So what is the formula we use? We use the formula 1 by F is equal to 1 by V plus 1 by U. This is the formula. So first let us draw the mirror, concave mirror. This is pole, this is focus, this is center of the curvature. The distance between pole and the center of the curvature is called radius of the curvature, that is 8 centimeters. Pole and center, this distance is radius of the curvature. So this is given 8 centimeters, right? So up to center 8 centimeter, then up to focus how many centimeters? No, F is equal to R by 2, 4 centimeter. Where is the object placed? Object is placed at 10 centimeters, 10. 10 means 10 lie between B and C. So object must be beyond C when the image is formed between F and C. Yes or no? Now we have to find the image distance. This distance is 10 centimeters already, that is given in the problem. Object distance. Now we have to calculate this particular distance, P to the I. This distance we have, image distance should be calculated. So 1 by F is equal to, image distance is calculated, so I change the formula. 1 by V is equal to 1 by F minus 1 by U. When plus 1 by U comes this side, minus 1 by U becomes. Sign convention, applying sign convention. Compulsory you have to apply the sign convention. Applying sign convention. Please do remember, you have to apply the sign convention before substituting the values. So U value negative, F value, focal length of the concave mirror is also negative. See, this is incident ray direction. When we measure the object distance, we are moving from P to the O this way. According to sign convention, all the distances should be measured from the pole, right? To measure this object distance, I have to move from P to the O. This way I have to go, but my direction is opposite to the incident ray. That is why sign to be taken negative. Focal length also, I have to move from P to the F. My direction is opposite to the incident ray. That is why sign to be taken negative. Sign convention already we have discussed. Okay. So 1 by V is equal to 1 by F value minus 4 minus U value minus 10. 1 by V is equal to 1 by minus 4, minus of minus plus 1 by 10. 1 by V is equal to 4, 10 LCM. 2 2s, 2 5s. 2 2s are 4, 4 5s are 20. 1 into, this is 4, this is 20. 4 5s are 20. Minus divided by plus is minus, plus 1 into, this is 10, this is 20. 10 2s are 20. First we have to write the numerator. And what is the denominator? L. 4. We have to see the LCM with this denominator. With what number we get this LCM? 4 5s are 20. Again you have to write the numerator. whatever the symbol we have, that symbol should be maintained. Numerator as it is we have, right? Denominator is 10, LCM is 20. In 10 table, when do we get to 20? 10 2s are 20. This way you have to do. Okay. 1 by v is equal to minus 5 plus 2 by 20. 1 by v is equal to minus 5 plus 2, how much nana? Minus 3 by 20. If you do cross multiplication, v is equal to minus 20 by 3. Minus 20 by 3, if you divide, you get 6.67 centimeters. So minus, we get minus. Why? So image also formed here. To measure this image distance also, we have to move opposite to the incident ray. For real images, sign to be taken negative. So this is the image distance. Okay. So applying sign convention is very, very important. That is why you have to remember the sign convention. For concave mirror, U is negative, V is also negative. For real images, it is plus. For virtual images, and focal length of the concave mirror is negative. Whenever concave mirror comes, you have to apply this sign convention. Already why these are negative, why this is positive, everything we have discussed in the previous video. Okay, I hope you are watching this video after watching that video, then only you will understand in a better way. Okay, so you have to watch the videos in order. If you go randomly, you won't understand, because we are going from step by step, step by step, step by step. Okay, so please do that. Please note down this problem and practice. So this is higher order thinking question. First problem. A convex mirror with the radius of the curvature 3 meters. So first we have to draw the convex mirror. So the radius of the curvature of the convex mirror is 3 meters. This is 3 meters. Radius of the curvature. The distance between pole and center of the curvature is called radius of the curvature. Used as rear view mirror. So the convex mirror is used as rear view mirror. So what is rear view mirror? Generally, any vehicle driver observe the vehicles which are coming behind with the help of one mirror beside him, right? That mirror is called a rear view mirror. Objects in the mirror are closer than they appear, because always the object distance is greater than image distance. Okay? At 5 meters, a bus is located at 5 meters. If a bus is located at 5 meters, let's say this is virtual focus, virtual center. Up to here 3 means the bus is located here. Then where do we get the image? Image we get between pole and focus, right? So find the position, nature and size of the image. Nature. So what is the nature of the image? This is image, this is object. Image is diminished. So why I am directly placing the position? Because already all the ray diagrams we have finished. The ray passes parallel to the principal axis. Okay. After reflection seems to be diverging from the focus. The ray seems to be passes through focus. After reflection passes parallel. If you extend them, where do you get the image? You get the images here. So because why I am not drawing the ray diagrams completely? Because already ray diagrams have been finished. If you practice those ray diagrams, this will be easy. Okay. If I say every time, so people who are watching the videos regularly, they may get bored. That is why I am not explaining the ray diagrams each and every time. One time I explain. That is, you have to understand. Now, we have to find the nature first. Diminished image. Image is diminished. This image is formed above the principal axis, so erect image. And this image is formed due to the diverging of the light rays, so it's a virtual image. We have to find the position of the image. That means V is question mark. Object distance is 5 meters. Focal length is 3 meters. Radius of the curvature is 3 meters. Then focal length is equal to R by 2. Okay, that is equal to 1.5 meters. Now we have to calculate image distance. 1 by f is equal to 1 by v minus 1 by u. 1 by f is equal to 1 by v should be calculated. So 1 by v is equal to 1 by f minus 1 by u. This is the formula. So 1 by v is equal to 1 by f value, how much? F value 1.5. But before going to substitute the values, we have to apply the sign convention. What is the sign convention of the convex mirror focal length? This is the real focal length. This focal length, to measure this focal length, all the distances should be measured from the pole, and we have to move from pole to the focus. This is our direction. Our direction is along the direction of the incident ray. That is why sign to be taken positive. Object distance, the distance between pole and object is object distance. We are measuring this way. Our direction is opposite to the incident ray. This is our direction. Incident ray goes this way. Then sign to be taken negative. So f value is positive 1.5 minus u value is negative minus 5. So minus into minus plus 1 by v is equal to, what is the LCM of 1.5 and 5? So LCM of 1.5 and 5 we have to do. If you go with the 3 into 0.5, 1.5, okay, or if you go with the 5 into 0.3, 5 3s are 15, 5 into 0.3, 1.5, 5 1 is 5. So 5 into 1, 5, 5 into 0.3, 1.5. So 1.5 is the LCM. 1 into, here 1.5, 1.5, so 1 into. In the 5 table, we have to get 1.5. That is possible with 0.3. 5 into 0.3. How much? 1.5. Then 1 by v is equal to 1 plus 0.3 by 1.5. Next 1 by v is equal to 1 plus 0.3, 1.3 by 1.5. So this can be written as v is equal to cross multiplication 15 by 13. So 15 by 13 if you get, you will get 1.15. 13 1 is 13, 2 is remaining 0.0, 13 1 is 13, 7 is remaining, 13 5s are 65. So 1.15 centimeters. See, v is positive because image is virtual. To measure this distance between P and I, we are moving along the direction of the incident ray. So that is why it is plus. Okay, for convex mirror focal length is positive, for concave mirror focal length is negative. Sign convention you have to remember. For sign convention of this convex mirror, u is negative, v is positive, focal length also positive. You have to remember the sign convention of the convex mirror. This sign convention should be used before substituting the values to get the answer in exactly. Okay, so this way we have discussed some problems which are given in the textbook. Some other extra problems also we will discuss. Okay.